Hello everyone. This video is about embedded vehicle black box for telematics and parameter logging. What if your car could tell you every second of data before an accident and send it to the cloud instantly? Speed, sound levels, and even cabin temperature, all captured in real time and transmitted wirelessly and visible on your phone anywhere in the world. That's exactly what we have built. A fully embedded vehicle black box using LoRa, CAN bus, ESP32, STM32, and a live IoT cloud dashboard at CDAC. And in this video, I'm going to walk you through every single part of it. So, our setup uses an STM32 as the primary controller. We have integrated a DST11 to monitor temperature and humidity inside the vehicle cabin, an IR sensor for obstacle detection, and an LM393 sound sensor to detect crash impacts, simulating crash detection. We also have an H2010 speed sensor which measures rotational speed in real time. You can see the complexity of the wiring here. We're using the CAN protocol to simulate a real vehicle's internal communication network. I've heard of flight data recorders, EDRs, so that is the original black box concept, and the same idea is now being applied to the cars. So we can capture speed, braking, throttle position, and the seatbelt status right before a crash. But traditional EDRs, the event data recorders, just store data locally. What we built goes much further. Our system logs all of the data and transmits it wirelessly to the cloud in real time. It can send emergency alerts over LoRa to nearby vehicles and shows everything on a live dashboard you can access on your phone. Node 1 is our proximity monitor, Node 2 is a vehicle unit. Alright, so let's jump into the actual demonstration part. So here on my screen we have started the PuTTY terminal, and we have the Arduino IDE. So this is the PuTTY terminal 1, terminal 2, sending and receiving data or the payload. And this is the STM32 Cube IDE. So here the code for STM32 microcontroller goes. So as you can see here, the CAN frames are getting transmitted and received on the respective STM32 board. So the telemetry sensor data is being sent from Arduino to STM32. And this is the serial monitor. This is how a packet would look like. It is now getting connected to the Wi-Fi, and the new data packet is sent, and it is publishing to ThingsBoard IoT dashboard. So all three terminals are in synchronization, and that is from Arduino to STM, STM to ESP32. The data flow is established. So first we will test the IR sensor and the alert system. You can see I have triggered the IR sensor, and the state is changed to 1, which means it has turned on and the buzzer goes on, and the status is detected as critical. So this is now sent to the things board. So you can see the timestamp. So we're testing again. So it is being sent to the cloud in real time. So you can see it is critical or safe at what time, and what is the latitude, longitude, where it happened, and the temperature, everything is being recorded. So these are the widgets on the things board dashboard. So we have formatted the JSON packet. Next we will test the crash detection via the sound sensor. So you can see when it has crossed the threshold, it says loud noise detected and the crash detected. So it's detected as a vehicle status as critical, and the same is sent to the dashboard. So you can see the sound has now changed. The sound value is 581. So you can have it as per the decibels. And next we will test the DHT11 sensor, which is to measure temperature and humidity inside the vehicle cabin. So you can see I have triggered the sensor and the temperature has now reached 30 degrees Celsius. And it says it is hot than expected. And the vehicle status is set to critical. Temperature is logged as 30 degrees. So you can see continuously 3 packets of critical information has been sent. All this in real time. So for the next step, we will see and test the rotational speed, which is to get the RPM and the idling time of vehicle. So this is the H2010 speed sensor. So you can see the motor is turned on, and the speed is recorded as 6.1 kilometer per hour. Acceleration is also calculated, and braking is set as no. And you can see in the widget right here, the RPM is crossing 3000 from 535 initial value. So every second it transmits the payload. So for now it is safe. And this is the entire dashboard with all the widgets for logging the respective parameters which are discussed above. And in the next one, we will be seeing the interesting part, which is the LoRa communication protocol. So you can see LoRa packet received. So from node 2 to node 1, and then the other laptop, in the terminal, we can see. So transmitting, I am in proximity of your node, be alert. So this is the transmitter side, it's constantly sends, and this keeps on listening. So you can see it has received from node 2. So let's say there is the obstacle detection happening, and we have got the vehicle status as critical. So the nearby vehicle could help. So potential crash is detected, and the same is being communicated to the vehicle in its proximity. So you can see the message which has happened in the car 1 is received on the car 2. So B2B communication using a LoRa between node 1 and node 2. So this we have tested across a few meters inside the classroom, around 4.3 meters. So it keeps on sending data that I'm in your vicinity, and this keeps receiving. And whenever some catastrophe happens, the same is sent to vehicle 1 for help. And in the next testing, we have decided to test the range of it. So now we are testing it across a distance of 10.3 meters. And it still communicates, it still works. The sequence numbers are being generated each second, and the data packets are getting transmitted and received simultaneously. So it is bidirectional and working perfectly. So you can see we have increased the range, and now is the node 1 is coming towards node 2, and as soon as it comes in the range, it catches the signal, and boom, you can see the packet LoRa transmission is successful. So that is the indication over here. Let's scroll up. Yeah, so there it is. You can see LoRa packet received from node 2. That is the project. Thank you so much.